A chemical bond is an attractive force that holds atoms together. The type of bond that forms depends largely on a property called electronegativity. Electronegativity is an atom's ability to attract electrons toward itself. Some atoms pull electrons very strongly, while others pull them more weakly. The difference in electronegativity between two atoms determines how electrons are distributed in a bond. If two atoms have very similar electronegativities, they share electrons almost equally. This forms a nonpolar covalent bond. If one atom is somewhat more electronegative than the other, the electrons are shared unequally and spend more time near the more electronegative atom. This forms a polar covalent bond. If the difference in electronegativity becomes very large, one atom can completely take an electron from the other. This process is called electron transfer and results in the formation of an ionic bond. Let's look at some examples of each of these bonds. Bonds in molecular hydrogen and molecular oxygen are examples of nonpolar covalent bonds. In a nonpolar covalent bond, neither atom pulls significantly harder on the shared electrons, so there is no significant charge separation. For polar covalent bonds, water is one of the most important examples. Oxygen attracts the shared electrons more strongly than hydrogen, giving water its characteristic polarity. And finally, for ionic bonds, a classic example is sodium chloride. Sodium readily loses an electron, while chlorine readily gains one. The resulting sodium and chloride ions are held together by electrostatic attraction. Although these electronegativity values exist on a continuum, chemists often use simple guidelines. Very small electronegativity differences generally produce nonpolar covalent bonds. Intermediate differences produce polar covalent bonds. Very large differences result in ionic bonds. Now that we understand how atoms are connected, let's look at the interactions that give biological molecules their structure and function. One of the most important interactions in biology is the hydrogen bond. A hydrogen bond forms when a hydrogen atom that is already covalently bonded to an electronegative atom becomes attracted to a nearby electronegative atom. Hydrogen bonds are much weaker than covalent bonds, but when many hydrogen bonds act together, they become extremely important. Hydrogen bonds are responsible for many of water's unique properties, including cohesion, adhesion, high specific heat capacity, and excellent solvent properties. Hydrogen bonds also hold complementary DNA strands together. Adenine pairs with thymine through hydrogen bonds, while guanine pairs with cytosine through hydrogen bonds. Another important weak interaction is the van der Waals interaction. Van der Waals interactions arise from temporary fluctuations in electron distribution. At any given moment, electrons may become unevenly distributed, creating temporary partial charges that attract neighboring molecules. Individual van der Waals interactions are very weak, but large numbers of them contribute significantly to molecular stability. Proteins, membranes, and many other biological structures rely on these interactions. And finally, we have hydrophobic interactions. Hydrophobic molecules are nonpolar and do not interact favorably with water. When placed in water, these molecules tend to cluster together, minimizing their contact with the surrounding water molecules. This clustering effect is known as a hydrophobic interaction. Hydrophobic interactions play a central role in protein folding and in the formation of biological membranes. Together, these bonds and interactions provide the foundation for the structure and function of biological molecules.